1.2 segment addition postulate. So the first thing is a line segment is part of a line with two endpoints. So it is part of a line with two endpoints. So here, if I have part of a line, x, y, and I have another point A on here, I could name this segment XA, I could name it segment XY, I could name it segment AY. So the segment addition postulate is if A, B, and C are collinear. So remember, collinear means that they all lie on the same line, and B is between A and C, then AB plus BC equals AC. So basically what this is saying, you have a segment and I have 3 points on there, A, B, and C. If I add up the length from A to B and I add up the length from B to C, it is going to equal the length from A to C. So here, if I have the length between A to B, so AB is 5 units, B to C is 1, 2, 3 units. That means the length of A to C from this point all the way down to this point is going to be 8. 5 plus 3 is 8. One thing to note here, which is kind of part of the notation, if I reference something as A, B, this indicates the actual segment, where AB with no line on top of it indicates the length. Super important to know. So I like to think of this as being an object and this as being a number or length, measurement, something like that. All right, moving on to our examples here. Find each, assume figures are not drawn to scale. So if I try to find x to z, that is the whole thing. So all we are going to do is add up xy, which is 4 and 5/8, and add up y to z, which is 2 and 1/2. And if you add those together, it is going to equal 7 and 1/8 inch. Right? Number 2, JM, JL, and KM. So JM, right here, 2.4 plus 3.8, which is 6.2. And then we are working with centimeters here. JL, so we're going to do this whole thing, 2.4 plus 3.8 plus 1.1, and that ends up equaling 7.3 centimeters. KM is just going to be that 3.8 centimeter. Okay, so number 3, find QR, so Q to R. So I need to find this part right here. I know part of it and I know the whole length. So you can look at it in 2 different ways. You can find, some people can see as 1 part plus 1 part equals a whole. So you can go ahead and say 6 and 5/8 plus 13 and 3. Oh, hold on 1 second, I messed that up. So 6 and 5/8 plus what will give me 13 and 3/4. Or some people can go ahead and see automatically that you need to take 13 and 3/4 and subtract 6 and 5/8. And that would end up getting you 7 and 1/8. And then LM here is the same thing, so I'm going to go ahead and have you try that one on your own. You should receive the LM is 1.4 centimeters. Okay, these ones over here are going to be a little bit trickier. So number 5, find X and ST if T is between S and U. So let's first try to draw a picture. So T is between S and U. So putting 3 dots on here, T is between S and U. If ST equals 7X, SU, so the whole thing is 45, and TU is 5X minus 3. We have to find X and ST. So again, you're just adding up the parts to it. So ST, we know, is 7X. And then T to U is 5X minus 3. So 5X minus 3. And it equals the whole thing, which is 45. Let's go ahead and combine like terms. 7 plus 5 is 12. X minus 3 is 45. Solve for this equation. Add 3. 12x equals 48. 12. We get x to be 4. So we found out what x is. And now we need to find out what ST is. So ST, they told us was 7x. Now let's plug that in. So 7 times 4. 7 times 4 is 28. So ST is 28. Number 6, find X and BC if B is between A and C. So again, let's set up our picture. If B is between A and C. AC is 4x minus 12. 4x minus 12, so that's the whole length. AB is x, and BC is 2x plus 3. So we need to set that one up. So we're going to add those two together. So again, AB is x, BC is 2x plus 3, and that needs to equal 4x minus 12, which is the whole length. Combining like terms, 3x plus 3 equals 4x minus 12. Let's get our x's on one side. So 3 equals x minus 12. X is 15. Then adding it back in, we are not done because it's asking us to find x and BC. So BC, they told us was 2x plus 3. So that's 2 times 15 plus 3, which is 33. Number 7, find x and BC if B is between C and D. B is between C and D. CB is 4x minus 9. BD is 3x plus 5. And CD is 17. I want you to go ahead and try that one on your own. So go ahead and pause the video here, try it on your own, and then play the video. Okay, so I got x to equal 3 and BC. Be careful here, they reference it as CB. It is the same thing. So CB is the same thing as BC. So BC is 3. All right, moving on. So congruent. Congruent are two things or objects that have the same length. Okay, so they have the same length. The symbol that we use for this is an equal sign with a little squiggly on top. So if I say that I write this statement, this means segment AB is congruent to segment CD. Okay, so it means is congruent to. Means it's the same exact measurement. If segment AB is 4 inches, that means segment CD is 4 inches. They are the same exact thing. Okay, so name the congruent segments in each figure. Here, you're just going to match up the number of dots or dashes. So 1 dash and 1 dash. Those two segments are congruent. So segment AD is congruent to segment BC. Same thing. Then we move on to, 2 dashes here. 2 and 2. Segment AB is congruent to segment DC. This one, start with just 1. So segment WJ is congruent to segment JX. They both have 1 dash on them. And then we can say, go to 2. 2 dashes, 2 dashes. So segment ZY is congruent to segment YX. Then moving on to 3 and 3. Segment WZ is congruent to segment. Now this one's not named, but it's talking about this whole segment right here. Okay, so segment WX. Number 10, the special thing about this one is you're going to have more than just 2 things being congruent to each other. So we have 1 dash here, 1 dash here. Segment LU is congruent to segment LM. 1 here and 1 here, which is congruent to segment S. R congruent to segment RQ. And as you should see, it doesn't matter if I reference this segment as RQ or QR. The order of them do not matter. Okay, moving on to 2. So we have MN has 2 dashes, and NO has 2 dashes, and OP has 2 dashes. Then 3, QP is congruent to TU, which is congruent to TS. All right, talking about midpoint, you should know what midpoint is. It is a point that cuts a segment in half. So for example, if B is the midpoint of segment AC, then you can say that points A, B, and C are collinear. And you can also say that AB will equal BC. So looking at here, let's draw a little figure. We have A, B, and C. Those segments are congruent to each other. Okay, so segment bisector is a segment, line, or plane that intersects a segment at its midpoint. So it's the same thing as a midpoint, except instead of we're talking about point, we're talking about a line, segment, or plane that would cut something in half. Number 11, RT is 42 inches, so R to T is 42. Find R to S. Well, those are the same length, so we can go ahead and cut 42 right in half to get 21. So RS is 21 inches. Point B is the midpoint of AC. Okay, so let's draw this out. So here's my segment AC. B is the midpoint. So those two segments are congruent. If AB is 5x and BC is 3x plus 4, find AC. Well, these are the same exact length, so let's go ahead and set them equal to each other. 5x should equal 3x plus 4. X is 2. And then AC is the whole length. So what is 5 times 2? 10. So I know that this segment is 10 and this segment is 10. So 10 plus 10 is 20. So AC is 20.